Okay, for this demo we're going to show you how your TI-89 can do integrals and derivatives, right? So to do so, up here in this F3 you see this calc function. So if we hit F3, down's going to drop all your different calc functions. So in addition to different derivatives and integrals, you can do limits, sums, you can do all sorts of really cool things here. Taylor series, all sorts of great things here. So let's just look at the most basic ones, derivatives and integrals, because we use these all the time. When you hit that, now you need to follow a certain set of rules. We're going to have a comma separating two expressions. The first expression is the expression that we want to take the derivative of, and the second one is the variable with which we want to take the derivative. So if it's like d function dx, then we need to put x there after the comma. And then before the comma we put the function, right? So maybe it's x squared. We want to take the derivative of x squared, and this is a simple one. We know that this should just be 2x. We do it and out pops 2x. But this can do much more complicated ones, right? This can do, you know, high order ones that are much trickier without any problem. You know, 5x squared and so forth. You could keep on adding it, and it has no problem taking these derivatives. Okay. Now how about integrals? Same exact approach. You're going to hit F3 to pull up this function, pull down your integral. This time you're going to type your expression here. All right, so let's do x squared again. X squared. You're going to tell it what variable to take the integral with respect to, x, let's say. And now you can actually bound the integral. You can do a definite integral, right? So you can say take it from this point to that point. So let's go ahead and say from 0 up until, say, 5. We want to take that, we want to evaluate that integral over that range, right? So that's the format: expression, comma, variable, comma, beginning, and then comma, end for your expression. And you're going to evaluate that, and out pops the integral. So that's how you take derivatives and integrals on your TI-89. Okay, your TI-89 can not only take derivatives and integrals, but it can do so with units, right? So let's look at our classic example of work being the integral of force over distance, right? So if you take the integral over this distance, applying that force as a function of distance, you can get the total amount of work. So let's do a simple example of this. Let's figure out the work necessary to lift a car on Earth 60 meters in the air, right? So to do this, we're going to hit F3. We're going to go to F3 and we're going to integrate over our force expression. So what's the force acting on a car? Well, it's equal to the weight of the car. Let's say it's 2,000 kilograms. So kg, that gives us kilograms. We need to multiply this by gravity. Now, in this case, this is one of the instances that gravity is actually a pre-programmed constant in your calculator. _g, that's the specific gravity constant. However, you could put it in yourself just as easily. It's 9.81, going to be meters, so you go _m divided by seconds, so we're going to go _s, and then that's squared, meters per second squared. Okay? So that is our expression for force. Now we just need to say, okay, the variable that we're integrating over, we can call it x, and it's going to go from 0 meters all the way up to 60 meters in the air. Okay. _m. And if we've done this correctly, this should spit out an answer in joules. Yeah, sure enough. When we integrate the force, right, over that entire distance, lifting it 60 meters in the air, we get an answer in joules. So it went from force to joules because it's keeping track of the units correctly here. And out comes, 1.1 e to the 6th, so about 1,000,000 joules of energy to make that happen.